Good morning, students. The next topic we are treating is calculation in solubility. As you have been taught, the types of solution: saturated solution, which is a solution that contains as many solutes as it can dissolve in the presence of undissolved solute, and an unsaturated solution is a solution that can still get more solutes than it can normally dissolve. We also treated supersaturated solutions, and we also look at the solubility curve. Supersaturated solution contains more solute that it can dissolve, but can dissolve when there is increase in temperature by heating. And you know that temperature affects solubility of solid. Increase in temperature increases the solubility of solids. Now we are looking at the calculation. We've been taught the solubility curve too, how to measure the solubility of different salts at different temperature. And you know that temperature increase decreases solubility of gases. Now let's look at this. We have a formula here for calculating solubility. We have other methods, but this is the most common method and the easiest method. Solubility. The solubility here, the unit is in mole per dm cube. That is how many mole we dissolve in 1 dm cube of water. We can also calculate solubility in gram per dm cube. In acid-base titration, we treated molar concentration, which is also a mole per dm cube, is equal to mass concentration over molar mass. We can use that formula to find solubility, whether in mole per dm cube or mass per gram per dm cube. Now let's look at this question. This formula: solubility is equal to mass over molar mass multiplied by 1000 over volume. That's the volume of the water or solvent that is used to dissolve it. Mass is the mass of the salt given, which is in gram. Molar mass is in gram per mole. That's for the compound you are calculating, the 2035. You find the molar mass, and solubility here is in mole per dm cube. This is a mass that will dissolve in the quantity of water. The volume of the water can be in cm cube or gram. Don't be confused with that. So let's look at this question. 23 grams of lead 2-triazonitrate 5 was dissolved in 40 grams of distilled water at 20 degrees Celsius. This temperature is not needed for the calculation. We only use it. Calculate the solubility of the solutes in mole per dm cube. This is a mole per dm cube now. This is the formula for calculating solubility of solutes in mole per dm cube. The mass of the salt given is 23. The formula for the salt is lead 2. The 2 will go to the other side. NO3 carries -1, so they exchange their valency. Lead 2-triazonitrate 5. Working out the mass number which will be given anytime you are given a question is 207 for lead by this 2 outside multiplied by 14 plus 16 times 3. Or we give you 331 gram per mole. That's the molar mass of the salt. Mass, which is 23, divided by molar mass multiplied by 100 over 40. The 40 here is the volume of the water, 40 gram or 40 cm cube. Now when you calculate this, you have a solubility of 1.74 mole per dm cube. That is the solubility of a salt, lead 2-triazonitrate 5, is when 23 grams of salt is added, is 1.74 mole per dm cube. Let's look at this too. 3.06 gram of a sample of potassium triazochlorate 5 was required to make a saturated solution with 10 cm cube of water at 25 degrees Celsius. The solubility of the salt is at 25 is what? Volume is 10 cm cube. The mass of the salt is 3.06 gram. The molar mass of potassium triazochlorate 5, K is 39, which will be given. Chlorine is 35.5 plus 16 of oxygen multiplied by 3. You have 122.5 gram per mole. Using the formula, solubility is equal to mass over molar mass times 1000 over volume. We have 3.06 of the mass divided by the molar mass, which is 122.5, multiplied by 1000 over the volume of the water, which is 10 cm cube. Can also be given as 10 gram at times, but it's not the mass. Now when you calculate that, you get 2.50 mole per dm cube. Now we have another question here. We have different ways in which the questions can be asked. At times you may be asked to determine if a solution is saturated or not, comparing the salt that if you don't have for a certain volume of water. Now if you had the mass of salt, a measured mass of salt to it, and the solution is not yet saturated, that is when you dissolve the salt in it, everything dissolves in the water and you are not seeing undissolved salt. By the time you continue adding more salt, at a point the salt will refuse to dissolve because you did not increase the volume of the water. You will see undissolved salts, they will still settle down. It means the solution is saturated. Now, when a solution is unsaturated, you can still take more salt for that volume of water because you are not increasing the volume of the water. Now, so the solubility of a salt of molar mass 101 gram, the salt was not given, so we don't know the formula, but the molar mass has been given. At 20 degrees Celsius is 0.34 mole per dm cube. The solubility has been given, which is this. If 3.40 gram of the salt is dissolved completely in 250 cm cube of the water in a beaker, the resulting solution is, they want you to know whether the solution is saturated or unsaturated. The solubility has been given to be 0.34 mole per dm cube. Using this formula, mass over molar mass times 1000 over volume. The mass of the salt is 3.4. The volume of the water is 250 cm cube. Now we've been given all the parameter, but we want to check whether this salt, the volume of the mass of salt added, fits the solubility. You can calculate in another way. You can calculate the solubility for 3.40. Use your mass here and find this. You will see that the solubility will be lower than 0.34. Now I decided to calculate this. X. I want to check whether this mass is actually what fits this solubility. So this is the solubility 0.34 is equal to X over 101, which is the molar mass of the gas here. You can calculate it out if the formula is given, but it has been given a question. Multiply by 1000 over 250, which is the volume of the water. When you cross multiply, you end up getting 8.585 gram of salt. So it means that the quantity of salt that can give a solubility of 0.34 mole per dm cube is 8.585 gram, not 3.40 gram. So it means that this 3.4 is little added to a volume of water which is 253. So it means it can take more. This volume of water can take more salts, that is up to 8.58 gram, before you can get a solubility of this at this. So the solution is unsaturated yet. Until we add it up to 8.58, it will not be saturated. And the last form of question here that we usually come across in calculation solubility is this. The solubility of sodium triazonitrate 5 is exactly 3000 gram per 1000 gram water. At its volume of water is 1000, the salt is 3000 gram at 100 degrees Celsius. And when there was a drop in temperature, the solubility, the salts that we have there is 1004. That is, the salt that dissolves is 1004 in the same 1000 gram of water. When the temperature drops, in the same 1000 gram of water. Calculate the mass of sodium triazonitrate 5 that will crystallize out of the solution. If we are using 3000 per 100 gram at this, and we are using 1400 per 1000 gram at this, you will get a certain mass that crystallizes. When there was a drop in temperature, we see that there was a drop in the salt that dissolved. We will get that one out by the subtracting. But now, if the mass of the sodium triazonitrate 5 that will crystallize out is 300 grams, what mass will it crystallize out? So 3000 at 100 degrees Celsius, 3000 gram of solute plus 1000 gram of the water, everything together make a solution of 4000. This is the solute and this is the solvent, that is the water. Solute plus solvent equals solution. Now, when the temperature dropped at 50, the solute here was 1004 in 1000 gram of water as well, to give you 2004 gram solution. We want to get that when the temperature drop, you don't need temperature in the calculation. Actually, when there was a temperature drop, the mass of salt that crystallized out should be subtracted. This was the mass of salt that crystallizes out when there was a drop in temperature. Now, they are asking that if it is 300 grams of saturated solution, if it is, what mass will it crystallize? It is 300 gram. Now, we have 4000 gram, deposit 16. This 4000 gram of the solution, original solution, crystallizes out 16 solute. 300 gram will deposit what? The original solution is 4,000 at the beginning. When you deduct it from this one, you get the mass that crystallizes out. So the question is 300 gram will deposit what mass of salt? Cross multiply 4,000 times x, 300 times 16. Divide both sides, you get 120 gram of solute. Now we have other questions on this. You can lay your hands on as many as possible, even in JAM questions. We can use solubility, we can calculate solubility in gram per dm cube using mass molar concentration equals to mass concentration over molar mass. Molar mass is gram per mole of the salt. Mass concentration is gram per dm cube, and this is mole per dm cube. We can use this formula provided what we are given fits the formula.